6 problems. Here we go. These are solving trig equations that are quadratic in nature. So let's look at this. First thing we want to say is they have 2 cosine squared of x minus the cube root of cosine of x. So do we have the same trig functions throughout? And we do. You'll notice like in number 16 we have different ones. We'll have to deal with that. But for now they're going easy on us. So this is quadratic in nature. You can think, if this messes you up, you can say, make up a variable like m. Let's let m equal to the cosine of x. Then m squared would be equal to the cosine squared of x. And you could rewrite this into 2m squared minus the square root of 3 times m. And then you could solve this for m and at the end replace it with cosine of x. I'm going to leave it in the trig function for now. I'm going to say, how can we solve this? I'm going to factor out, this has a cosine squared and this has a cosine. I'm going to factor out a cosine x from both of these terms. And if I do that, I'm left with 2 times the cosine of x minus the square root of 3. And so then I'll use the zero product property. I'll say this will be true when either this factor equals to 0 or this factor equals to 0. So I'll say, when is the cosine of x equal to 0? And when does 2 times the cosine of x minus the square root of 3 equal to 0? I'm going to solve this for the cosine of x. So I'll add the square root of 3 and then I'll divide by 2. And then I'll think about, when is this true? Now this is an x, so I'm going to answer in radians. And they gave me over from 0 to 2 pi. Where is the cosine 0? Here and here. So this one gives me 2 answers. X is pi over 2 and 3 pi over 2. All right. When is the cosine square root of 3 over 2? Well, that's where the cosine is positive, here and here. So this is pi over 6, and this is 11 pi over 6. So my 4 answers here, I got 4 answers here. I got pi over 2, 3 pi over 2, pi over 6, 11 pi over 6. I guess the most appropriate way would be to write it from smallest angle to largest angle, but this is a list. If it appears on the list, I'm good. All right, let's do 15. This does not have a 0 on the right-hand side, so first get a 0 on the right-hand side. So let's do this. 2 sine squared of x minus the sine of x minus 1 equals to 0. And if you want to do it with the substitution of m, that would be 2m squared minus m minus 1 is 0. Factor this and solve for m, and at the end substitute sine x for m back at the end. We're going to try to factor this. I'm going to use the AC method. 2 times negative 1 is negative 2. I need 2 things to add up to be negative 1. Negative 2 times positive 1 will give me negative 2. Negative 2 plus 1 gives me negative 1. So I'm going to use my factoring. Maybe I'll factor this m and get this to factor. I'll do my factoring method, what we already discussed. And we'll get this to factor into 2m. It's going to factor into this. Let's see, 2m squared, negative m, negative. So this factors into 2 sine x plus 1 times the sine of x minus 1. Then you set each factor equal to 0. Well, this will be true when the 2 sine x plus 1 is 0, or when the sine of x minus 1 is 0, or when the sine of x is 1, or when the sine of x, you subtract 1, divide by 2, is negative 1/2. So you ask yourself, where is the sine 1? Well, it only happens one time when you're going around the unit circle, and it happens right there. And so this gives us an answer at x is pi over 2. Then you ask yourself, where is the sine negative 1/2? Well, it's negative 1/2 here and here. And so you say, well, what are those values of x? And this one is when x is 7 pi over 6. And this one is going to be 11 pi over 6. So we got 3 answers from that one. And so these are pi over 2, 7 pi over 6, and 11 pi over 6. Those are our three answers. All right, the next one, what is the deal with this guy? He's got two different trig functions in him, so we have to figure out how to deal with that. But factoring saves the day. We don't have to rewrite anybody into one type of function. Let's get a 0 on one side and see what we can do. So let's get a 0 on the side. Minus the cosine of theta is 0. And what could I do with that? Well, they have a common factor of cosine of theta. So let's factor him out. So let's do that. We have the cosine of theta. What are we left with? The sine squared of theta minus 1 equals 0. Oh, could I factor this further? This is difference of squares. It's something squared minus something squared. So we can factor this guy further. This is the cosine of theta times the sine of theta plus 1 times the sine of theta minus 1. So we have three factors. This will be true when any one of these factors equals to 0. This will be true when the cosine of theta is 0, when the sine of theta plus 1 is 0, or when the sine of theta minus 1 is 0. When is the cosine 0? It's 0 here and here. So this gave us two answers. This is 90 degrees and this is 270 degrees. We'll solve for the sine theta. So when is the sine of theta negative 1? Well, the sine of theta is negative 1 down here at 270. But that's already on our list, so we're fine. We don't have to talk about him. When is the sine of theta equal to 1? Well, that's at 90 degrees. So we already have that on our list. So this is all our answers for that one. All right, cool. What else have we got? Let me look at this for a second. Okay, I'm okay with that. We've got this one. Let's get a 0 on one side. So let's see. 4 times the cosine squared of theta plus 5 times the cosine of theta plus 1 equals to 0. I'm going to use the AC method to solve this, to factor this. And once I have it factored, this is what it ends up being. I just don't want to take all that time because we already went through that. This factors into 4 cosine of theta plus 1 plus 1. Let's see, 4 cosine squared of theta plus 5 cosine of theta plus 1. Okay, so this will be true when the cosine, 4 times the cosine of theta plus 1 is 0, or the cosine of theta plus 1 is 0. So this will be true when the cosine of theta is negative 1, or when the cosine of theta is negative 1/4. Now, this one's a little tricky because this is on the unit circle, but this is not. So we'll have to use our calculator. And this is in degrees, so because they said theta. So let's look at this. Where is the cosine negative 1? Right here. So this guy gives us theta is 180. All right, cool. Where's the cosine negative 1/4? So let's do that. Take the inverse. Oh, wait, what mode am I in? I'm in degree, okay. I'm on the inverse cosine of negative 0.25 or negative 1/4. And so this gives me 104.5 degrees. So this guy gives me 104.5 degrees. But if you'll recall, right, there's two answers that will give me that. The cosine is positive. Let's see. I'm sorry, the cosine is negative right here. And it's also going to be negative in this quadrant. So how are we going to find that second answer? Well, this is maybe one of the hardest ones we'll have to do. This one is 104, right? 0.5 degrees. So we got to figure out how much of this is from the horizontal axis. So to get that, we subtract. We take 180 minus that, minus 104.5. And it tells us that this much is 75, this much right here is 75.5 degrees. So to get this other angle, we're going to take 180 plus 75.5 degrees. And that gives us 255 to 55.5 degrees. So what were our answers for 17? They were, the first one we got was 180 degrees. The second one was 104.5. And the third one is 255.5 degrees. You guys are doing great. 2 more problems and we're done. Let's look at 18. This has got cosine and sine in it, but it is in difference of squares form, so we can factor it very easily into this. This will be cosine of theta plus the sine of theta, cosine of theta minus the sine of theta. A squared minus b squared factors into a plus b times a minus b. When will this be true? This will be true when the cosine of theta plus the sine of theta is 0, or when the cosine of theta minus the sine of theta is 0. This will be true when the cosine is equal to the opposite of the sine. This one will be true when the cosine is equal to exactly what the sine is. So where does that happen? Well, at the 45s, in quadrant 1, at the 45-degree angle, sine and cosine are both 1 over the square root of 2. And in quadrant 3, the sine and cosine are both negative 1 over the square root of 2. This is where they're same. So this is where this is happening. We got 2 answers from that guy. This is 45 degrees. And then 45 plus 180 is the 225. Now how about this guy? Where on our unit circle are the sine and cosine the same value, but one's positive, one's negative? Oh, that's going to happen here in quadrant 2 and here in quadrant 4, where the sine and the cosine's negative 1 over the square root of 2 and the negative, and the sine is 1 over the square root of 2. And in quadrant 4, cosine, sine. So they're opposite. So this one is at 135, and then at 315. So that's how we figured out number 18. All right, number 19, last one. I put this one in here because it doesn't factor. We can try to make it factor. 8 times c is 6. We want 2 things to multiply together to get 8, and we can't make that happen. So we can't factor that with whole numbers. So I'm going to use quadratic formula. So I'm going to mimic this trig function off of just a regular quadratic. So x is negative b, negative 8, plus or minus the square root of b squared, 64, minus 4 times a, which is 3, times c, which is 2, all over 2 times a, 2 times 3, which is 6. And I'm going to solve this for x. So let's do this. X, but here's what x is defined to be. X represents the sine of theta. So want to keep that in mind. So we're going to just simplify this. This is a negative 8 plus or minus 64 minus, let's see, 4 times 3 is 12, times 2 is 24. 64 minus 24 is a 40 over 6. This is negative 8 plus or minus. If I think of 40 as 4 times 10, I can take the square root of the 4, which is a 2, root 10 over 6. I can divide the numerator and the denominator by 2, and that gives me negative 4 plus or minus square root of 10 over 3. My 2 answers here are negative 4 plus the square root of 10 over 3, and negative 4 minus the square root of 10 over 3. So let's just get some values out. Negative 4 plus 10 is, square root of 10. Negative 4 plus the square root of 10 is, I get about negative 0.8377. Then I'm going to divide that by 3. And this gives me negative 0.2792. Now what does this represent? This is equal to the sine of theta. How will I get theta? I'll take the inverse sine of that value. So I'm going to say the inverse sine of my answer, and that's going to give me theta is negative 16.21. Okay, we'll deal with the fact that it's a negative angle. We'll make it positive by adding 360, and we'll have to find our second value. Let's go down here and catch this guy. What is negative 4 minus the square root of 10 is negative 7.16. Let's divide that by 3, and that gives us negative 2.387. If we try to take the inverse sign of that, we're going to get an error because that is outside the range of the inverse sign. Sign only goes between negative 1 and 1, so we get no solutions from that particular answer. That's fine. Let's just deal with the one we did get. All right, right here, negative 16.27 here. That's one of my answers. But I don't want it to be this. I want it to be a positive. So I'm going to add 360 to that. So 360 plus negative 16.2. One of my answers is 343.8 degrees. All right. Where else is the sign negative? Because this was a negative sign value. Let me just double check something real quick. Make sure I'm telling you the truth. Yes, okay. So where else do we have another negative sign value? It's also negative in quadrant 3. So if this much is 16.2 degrees, so is this much. How can we get the positive angle 180 plus 16.2? Oops. 180 plus 16.2 gives me 196.2. So these are my two answers for number 19. So that's an example where we could not use factoring, which is so awesome and handy and dandy, but we had to use a different method, and we can still get there because quadratics are easy. All right, that's that one.